Hello, and thank you for watching this webcast tutorial. I'm Michael DeLuca, Go-to-Market Manager in the Industrial Solutions Division of ON Semiconductor's Image Sensor Group, and I'm happy to talk to you today about high-resolution image sensors that provide the highly detailed, highly uniform images that are required in very demanding industrial applications. Today, many industrial applications rely on imaging to increase productivity, reduce waste, and improve performance. Applications ranging from traffic monitoring and license plate recognition to barcode scanning, robot guidance, machine vision, and more are built around imaging systems and the productivity benefits they can bring to these applications. Since the specific needs of these different applications can vary greatly, the critical parameters used to select the most appropriate imaging system can also vary by application, sometimes requiring high frame rate, others broad dynamic range or low light sensitivity, or some different imaging parameter. But sometimes the most critical imaging specification for an application is capturing the highest level of image detail, being able to apply as many pixels as possible to a scene while still retaining a high level of image quality and uniformity. A good example of this is end-of-line inspection of flat panel displays, whether the display found on the smartphone in your pocket, the television in your living room, or even the computer monitor you may be watching this presentation on now. As part of the final inspection of these displays, high-resolution cameras are used to confirm the proper operation of each individual pixel in the display, down to the red, green, and blue substructures present within each of the pixels. And as the output resolution of these displays continues to increase from 1080p to 4K or Ultra HD and beyond, the camera resolution required to inspect these displays continues to increase as well. Other examples of this type of high-resolution imaging are aerial photography, where additional resolution in the camera provides higher detail in the final image, and high-end surveillance, where high resolution allows a broad scene to be captured at a level of detail that allows any portion of the scene to be enlarged to reveal critical information. But in addition to simply requiring high resolution, however, there is an additional element common to all of these applications, the need for high quality images. Images with high uniformity, low noise, high dynamic range, all of the things in addition to simple pixel count that are required in order to produce a detailed image. In other words, not only do these applications require a lot of pixels, they need each of these pixels to be of high quality as well. And that is one reason that even today, these applications often rely on CCD image sensors because of the unique performance this technology can provide. Interline Transfer CCDs retain outstanding image quality even when scaling to very large optical formats, enabling the development of devices that combine high resolution with high uniformity and low noise. The technology provides essentially a perfect global shutter for the capture of moving objects without the introduction of imaging artifacts, and broad exposure control enables a wide range of exposure conditions to be supported, including exposures less than a few microseconds or longer than 1 second, which can be vital in some applications. ON Semiconductor has supported these demanding imaging applications with high-resolution interline transfer CCD devices for 15 years, beginning with launch of the 11-megapixel KAI-43140 in 2003. This device was designed in a 35mm optical format, making it compatible with a variety of lens options in order to simplify adoption and integration of the device into different imaging workflows. It was followed by additional sensors that retained this 35mm format but increased resolution through the use of smaller pixels, finally advancing to the 29-megapixel KAI-29050 that is widely used in these applications today. In 2015, we increased resolution again, but this time not by developing a new pixel architecture, but by expanding to a larger optical format. The 47-megapixel KAI-47051 set a new bar for high-resolution, high-performance image capture, and in fact remains the highest resolution interline transfer CCD commercially available. But even with this success, some customers were looking to increase resolution while retaining the 35mm optical format, which would allow them to leverage their existing 35mm format infrastructure. In addition, the multi-tap output design of the KAI-47051 requires a sophisticated camera design, which can act as a barrier to adoption for some camera manufacturers. In short, the KAI-47051 is an outstanding solution for high-resolution imaging, but an opportunity still existed for a new device that increased resolution while retaining 35mm optical format. Doing this required the development of a new pixel, one that is smaller than the 5.5 micron pixel used in existing devices. The challenge, however, is developing that pixel in a way that retains, or even improves upon, the key image performance parameters that are required in these applications. Things like image uniformity, dynamic range, noise floor, and more. This becomes a challenge as pixel geometries are reduced, requiring the development of advanced pixel designs to retain these key performance parameters in the smaller pixel. Even though these applications are looking for increased resolution, they don't necessarily want to slow down the image capture process as a result, which then requires the use of higher bandwidth outputs to deliver this increased resolution at the frame rate required by the application. And ideally, any new image sensor would support an easy upgrade path from existing camera designs, both for camera manufacturers as well as end customers, requiring all of these improvements to be incorporated in a way that retains design similarity with existing devices. These challenges were met in the design of the new KAI-43140 image sensor. This device increases the resolution available in 35mm optical format to 43 megapixels, a 50% increase compared to the benchmark KAI-29050. Output bandwidth of the device has been increased so that the final frame rate is the same as that available from the 29050, even with these additional pixels. And because it is based on Interline Transfer CCD technology, the KAI-43140 combines this high resolution with world-class image uniformity and image quality, providing a simplified upgrade path for camera manufacturers with an existing camera design. The key enabler for this device is a newly designed 4.5 micron interline transfer CCD pixel, which is being deployed in the KAI-43140 for the first time. This pixel enables a 50% increase in resolution at a given optical node compared to a 5.5 micron pixel, raising resolution at the 35mm format from 29 megapixels to 43, and providing the additional detail required for these high-resolution applications. In addition, the maximum readout speed supported by the output amplifiers on the image sensor has also been increased compared to the prior generation design, allowing the KAI-43140 to support this increased resolution without sacrificing frame rate. But even as pixel size was reduced, the key imaging performance specification of the device were retained. Dynamic range and smear rejection remain at or above critical levels, and image uniformity has actually been increased compared to the KAI-29050 through the use of an advanced process design that eliminates an entire class of uniformity artifacts. And since the device is designed using Interline Transfer CCD technology, it continues to provide features such as electronic shutter and broad exposure support that remain the hallmarks of this technology. The KAI-43140 also provides a simplified upgrade path for camera manufacturers that have an existing camera design for ON Semiconductor's 5.5 micron family of CCD image sensors. The KAI-43140 uses the same package as the current 29 megapixel device, and in fact, the existing camera design can be modified to support the new device with only minor electrical changes. This design similarity, where camera manufacturers can easily leverage their existing camera design to support the new device, speeds time to market for camera manufacturers bringing out a new camera, and enables end customers to take advantage of the increased resolution and performance available from the KAI-43140 more quickly. To help in the development of new camera designs, evaluation kits are also available that enable detailed evaluation of the new device, supporting both full resolution still and video capture, ROI readout, pixel binning, and more. Full documentation is available describing the evaluation system, which simplifies the work needed either to get started or to use the evaluation kit as a reference in the tuning of a final camera design. With availability of the KAI-43140, ON Semiconductor's portfolio of high-resolution CCD image sensors is unmatched, allowing the best combination of resolution, features, and performance to be selected for each individual high-resolution application. The 43-megapixel KAI-43140 is the highest resolution interline transfer CCD available in 35mm format, while the 47-megapixel KAI-47051, the highest bandwidth device available in our CCD portfolio, remains the world's highest resolution interline transfer CCD. The 29-megapixel KAI-29050 continues to provide a compelling combination of high resolution with high imaging performance, while the 29052 provides that same resolution with enhanced near-infrared sensitivity. And devices such as the 16-megapixel KAI-16070 and 11-megapixel KAI-11002 use even larger pixels in this 35mm optical format to balance resolution with light sensitivity for applications requiring that option. In the end, this integrated portfolio provides multiple options for resolution, bandwidth, and light sensitivity, all without sacrificing the critical performance and overall image uniformity that these demanding applications require. This gives end users an unprecedented ability to match the best imaging device to their specific needs of the application, while allowing camera manufacturers to leverage their design resources in support of the full portfolio, expanding the options available to support the growing need for very high resolution, high quality image capture. For more information regarding these products or our complete portfolio of products, please contact your local sales representative or authorized distributor. Please visit us on the web at onsemi.com.